Now, in this video, we are going to take up one more problem on projections of lines, the problem number 61. The top view of a line capital PQ is 75 mm long, measures 50 mm, and the end capital P is 30 mm in front of VP and 15 mm above HP. The end capital Q is 15 mm in front of VP and above HP. Draw the projections of the line and find its inclination with HP and VP. Find the length of front view and the distance between the end projectors. So first we're going to try to analyze this problem in 3D. He says the end capital P is 30 mm in front of VP and 15 mm above HP. So when you look from the front view, we can see the distance 15 mm above HP. So when you look from the front view, the image is projected on the vertical plane. You're going to mark this point as P dash, which is also marked as capital P, which is 15 mm above HP, and 30 mm in front of VP. So when you look from the top view, we can see the distance 30 mm in front of VP. So this distance, when it is look from the top view, is projected onto the horizontal plane. You're going to mark this point as small p and also capital P. And he also says the NQ is 15 mm in front of VP. So when you look from the top view, we can see the distance between in front of VP by 15 mm. And you draw a dash dot line and say this is the locus of Q. So there the other end of the top view and the other end of the true length will go into line. So he says the top view of a line capital PQ is 75 mm long. So he has given the true length. So with small p as center, taking the radius of 75, cut an arc on the locus of Q in the top view, so that you will going to get this point as Q2. Then since it is the true length, you mark this as capital Q2. Then you join P and Q2 with a little bit thicker than the XY line. And also he has given the top view. So from P you measure a distance of 50 mm and draw an arc on the locus of Q, so that you will going to mark that point as small q. So join P to Q with a dark line. So we have the top view and now we have the true length also. Once you have the true length in the, now as we know the top view, the front view of the point Q dash should lie on this end projector. So from Q you draw a horizontal projector here and then you take it to the front view, and where you need to find out where will going to be the Q dash which will going to lie on this vertical line. So to get that, we should have the true length in the top view. We know that capital P and capital Q2 is the true length. Since it is a true length in a horizontal plane, obviously those 2 points should be above HP by same distance. So that means capital P is 15 mm above HP and also capital Q2 is 15 mm above HP. So that is the reason why we have the true length in the top view. So when you look from the front view, that P is projected here, so that you will going to get P dash, and that Q2 when it is projected, you will going to get P dash Q2 dash. So you got the front view of that particular true length line, which is Q2 dash. So that is what capital P and Q2 which is in space. Since we have the locus of Q in the front view, so since you have the locus of Q, so from here you draw a vertical projector in the space perpendicular to the HP. So with P as center, taking the radius of PQ2, you rotate it such that Q2 will lie on this particular end projector here in this space, so that it will go into cuts here. So you are going to get the point capital Q. So when you are projecting this onto the vertical plane, so that means when you are looking from the vertical plane, what happens? The image will start rotating from Q2 dash on the vertical plane. So when it is with P dash as center, so P dash Q2 dash as the radius, it is rotating such that it will go into cuts on this particular end projector line, which is this end projector line, the end projector line of this line, that is from Q dash you have a vertical projector. So that vertical projector is same as this vertical projector here. So that you will going to get the point Q dash, then join P dash Q dash with a dark line, so that you will going to get the front view. Now we have P and Q, capital P and Q, which the line in space. Now we have, this is the front view, we got the front view. Now we need to get the top view. So to get the top view, again with P as center, taking the radius of PQ, rotate it such that both P and capital Q1 are in front of VP by 30 mm. So when you look from the top view, you can see that Q1 is falling here. So on the horizontal plane, small p Q1, which is the line which is parallel to VP. Since it is parallel to VP, so you are getting the true length in VP. So you are projecting from Q1 so that it will going to come here, and then from here you draw a vertical projector so that it will going to cut the locus of Q here, and you mark this point as Q1 dash and write this as the locus of Q in the front view, and you mark this as capital Q1. So this is how you will be able to, and of course we will go to get the angle theta, which is the true inclination with respect to HP, alpha, it is the apparent inclination with respect to HP, and phi, which is the true inclination with respect to VP, and beta, which is the apparent inclination with respect to VP. So this is how you will be able to analyze this problem in 3 dimensions. Now when you want to go to in the stepwise, we can see here we have considered, so we have the true length in the horizontal plane, considering the true length in the horizontal plane. So that means when the line is parallel to HP, so we are getting the true length in the horizontal plane. So since we are looking from the front view, we can see that both P dash and Q2 dash is above HP by 15 mm. So when you are rotating, so from Q, so we have an end projector Q. So you draw a vertical projector from Q here, so that it will going to come here, but we don't have the locus of Q. So that is the point which I need to find out. With P as center, P and Q2 dash as the radius, you rotate that line in space so that it will going to cut on this end projector line Q, so that you will going to get the capital Q here. So this is the line what you get in space. So correspondingly, when you are looking from the front view, the image will start rotating from P dash as center, Q2 dash as the radius, so that it will going to cut on this end projector line till here. So you got this Q dash, that is P dash Q dash, draw a dark line here. So you're going to get the locus of Q in the front view. So that is what we have done here. So we have considered PQ and also PQ2. So since it is the true length in the horizontal plane, obviously P dash Q2 dash is parallel to HP. So since it is parallel to HP, so you are getting the true length here. So since it is the true length, therefore you will going to get it is parallel to HP. So once you get this, so from P dash, you take the P dash Q2 dash as the radius, you rotate it such that it will going to cut on this end projector line, so that you will going to get the point Q dash, then join P dash Q dash with a dark line, so that you will going to get the apparent inclination with respect to HP, and you have the locus of Q in the front view. So once you do that, now we will go for the true length. Now we need to find out the true length in the vertical plane. So to find the true length in the vertical plane, with P as center, taking the radius of PQ, you draw an arc such that both P and rotate the line such that both P and Q1, capital P and capital Q1 are in front of EP by 30 mm. So when you are doing that, what happens in the horizontal plane when you are looking from the top view? So Q is here, the vertical projector of this will going to lie here. So as I'm rotating in space that P and Q, what happens? This P and Q, with P as center, Q, small q as the radius, which will going to be rotated till both P and Q1 will going to become in front of EP by same distance, that is 30 mm. So now this is the line which is parallel to VP. So once the line is parallel to VP, now we are looking from the front view, because I need to find out the true length in the front view. So when you are looking from here, what happens? This is the line which you are projecting, which is that line. That line will going to become from here to here you are projecting. And when you look from the top view, that is the one which is going to be projected till here. And when you are looking from the front view, this is the line which you are trying to project, which is that line. That line will be from here to here. So it will going to cut the locus of Q in the front view, so that you will going to get Q1 dash. As we know that this is the true length in the vertical plane, obviously capital PQ1 is also parallel to VP, so it is the true length. So join P dash Q1 dash with little bit thicker than the XY line. So here you are going to be able to measure the true inclination with respect to HP. So this is how you can analyze in 3D, but here also we can see in the top view you are making rotation and make it parallel to VP, and you are projecting so that you will going to get P dash Q1 dash, which is capital P and Q, which will going to be the true length in the front view. So you will be able to measure the true inclination with respect to HP. So this is how you can analyze both in 3D as well as in the orthographic view by stepwise. Now we will try to solve this problem by using the sketchbook. So to do that, first we will go to draw the XY line and mark VP and HP. So as it says, the 30 mm in front of VP. So from XY line, you measure 30 mm and draw a horizontal line here. And similarly 15 mm above HP, so from XY line you take 15 mm and draw a horizontal line. And consider any point on these two horizontal lines and draw a vertical projector so that it will going to cut the two lines at P dash and P. Mark this as small p dash and small p, and here capital P and capital Q. And he has also said the NQ is 15 mm in front of VP. So in front of VP you take 15 mm and draw a horizontal dashed out line, and you mark this as locus of Q. As we know that the top view distance is 50, by using the compass with small p as center, taking the radius of 50, cut an arc on the locus of Q so that you will going to get the small q here. Then join capital join PQ with a dark line. Similarly, by using the compass, you measure a radius of 75 with small p as center, cut an arc on the locus of Q, and you mark this point as Q2, and you join P and Q2 with little bit thicker than the XY line. As we know that this is the true length, you mark this as capital P and capital Q. As we know that we have the top view line, since the front view of the point Q dash should lie on this end projector. So from Q, you draw a vertical projector to the front view, and we will not be knowing the locus of Q. That is the one which we need to find out. To find out the front view, you have to take the true length in the top view. We know that P and Q2 is the true length in the horizontal plane. Obviously, that line should be parallel to HP. So parallel to HP can be seen in the vertical plane. Now we have already P dash, but we need to find out where is Q2 dash. P dash is above HP by 15 mm. Therefore, Q2 dash should also be above HP by 15 mm. Then only the line will be parallel to HP. So because he says it is the true length in the horizontal plane. So from Q2, you draw a vertical projector such that it will going to touch the locus of Q in the front view, and you mark this point as Q2 dash. Then using the compass with P dash as center, taking the radius of P dash Q2 dash, you draw an arc such that that arc will going to cut on this end projector line Q in the front view, and you mark that point as Q dash and join P dash Q dash with a dark line. And then you will going to get the locus of Q, draw a dash dot line, horizontal dash dot line with a thin line, and you mark this as locus of Q. Now we need to find out the true length in the front view. So to find out that, by using the compass with P as center, taking the radius of PQ, draw an arc such that both P and Q1, small p and Q1 will be in front of VP by 30 mm. So now the line will be parallel to VP. Once the line is parallel to VP, you are getting the true length in VP. So from Q1, you draw a vertical projector so that it will going to cut the locus of Q in the front view, and you mark this point as Q1 dash. And as we know that this line is parallel to VP, so you're getting the true length. So you mark this as capital P and capital Q. Join P dash Q1 dash with little bit thicker than the XY line, which will going to be, obviously, it will going to be the true length. Now we need to find out the distances here. He has given, so theta and phi are the true inclination with respect to HP and VP. Alpha and beta are the true apparent inclination with respect to HP and VP. And also the distance D, distance between the end projector D, which you need to find out, and also the length of the front view P dash Q dash. So by using scale, you measure the distance of P dash Q dash, which will going to be 74 mm when you are doing it in manual. When you are doing it in computer, it will be 73.48. And also similarly, you measure the distance between the two end projectors, which will be 48 mm when you are doing it in manual. When you are doing it in computer, it is 47.70. And by using the protractor, you measure an angle of theta, which will going to be 48 degrees. And also alpha, which will going to be 49 degrees. But when you are doing it in computer, it will be 49.53, and this is 48.19. Similarly, by using the protractor with P as center, measure the angle of true inclination with respect to VP, which is phi, which is 11.54 when you are doing it in computer. When you are doing it in manual, it will be 12 degrees. And also with same center P, you measure the angle of apparent inclination beta with respect to VP, which is 18 degrees, or it will be 17.46 degrees. So this is how we will be able to and show all other dimensions, and this is how you will be able to solve this problem using the sketchbook. Thank you.